One way that we can convert a repeating decimal to fraction form is by following these 4 steps. So let's do that with the repeating decimal we have here, example A. So firstly, we set the repeating decimal that we do have equal to a variable, and the simplest one to use is just x. Now, for step 2, we look for how many decimal places it takes before a repeating pattern occurs. With this simple repeating decimal, it's just one decimal place, and then we have repeating 6s, one after the other. Now the importance of that is that we multiply a repeating decimal by a power of 10, depending on how many decimal places it took before the repeat. It just took 1, and 10 to the power of 1 is just 10. So let's multiply by 10. Now on the right side, x multiplied by 10 simply gives us 10x. Now on the left side, multiplying this by 10 will move the decimal point 1 place to the right. So we'll have 6 point followed by a repeat of 6s afterward. So now that we have done step 3 and our multiplication by a power of 10 is done, we have our first equation followed by our new second equation. And step 4 says we subtract the first equation from the new one. So let's do that. So we have 6 point followed by 6s equal to 10x. We're subtracting 0 point followed by 6s. That's equal to x. So on the right side, 10x minus x leaves us with 9x. Now on the left side, the first decimal, when we subtract the second decimal, is that the decimal expansion disappears. It's being subtracted away. And 6 minus 0 just leaves us with the number 6. So now, having followed these 4 steps, we have eradicated the decimal expansion. What we're left with, 6 equals 9x. So if we divide both sides by 9, 6 over 9 equals x. So solving for x, this can be simplified to 2 over 3. So the final part is to solve for x, which we have. So this repeating decimal is in fraction form, as we found out with this method, is 2 over 3. We can try the same approach with the repeating decimal here, example B. Firstly, set equal to a variable. We can again use the letter x. Now here, we go 1, 2 decimal places before we start to get a repeating pattern. So 10 to the power of 2 is 100. So we multiply the equation we have here by 100. So on the right side, x multiplied by 100 gives 100x. On the left side, multiplication by 100 moves the decimal point 2 places right. So 90 followed by a repeating pattern after the decimal point. So again, we have the first equation, and then we have our new second one. So it's this second equation minus the first one, like before. So let's proceed and see what we get. $100x minus x gives us 99x, and on the left, like what we saw with example A, the decimal expansion disappears. 90 minus 0 just leaves us with 90. So solving for x, we have 90 over 99 equals x, and this can be simplified further to the fraction 10 over 11. So a fraction form of this decimal expansion repeating in example B is 10 over 11. Now just for another example, we'll look at C, where we have a non-zero digit on the left of the decimal point, but we'll show that this doesn't matter, as the same approach can work. So we'll firstly set equal to a variable. Doesn't always have to be x, we'll go with b. Now this is the same repeating decimal expansion as we saw in b, so we know the multiplication is by 100 that we want to do. So again, move the decimal point 2 places right, and b multiplied by 100 is 100b. So the second equation we have, and then we subtract our first equation that we had here. Let's see what we get. So 100b minus b, so it's 99b. And on the left side, it's the same as before. The decimal expansion will disappear, and we're going to be left with 390 minus 3, which is 387. So we are to solve for b now, and if we divide both sides by 99, (387 over 99 equals b), and this can actually be simplified a bit more to the fraction 43 over 11. So for this repeating decimal, converting it to fraction form gives the fraction 43 over 11.